Yes, thank you. Sorry, no lunch yet, but I'll try to increase the technical complexity here over the previous talk. Is this? It was blinking a moment, or maybe that was just me. Yeah. So I'm a Postgres developer. I work at EDB on Postgres development, and this talk is sort of a summary and assessment of something I've been working on and researching the last 2, 3, 4 years. And this is something I've run into a lot in my work, and so I want to explore this topic. And this is probably going to be a lot of technical information, and each slide could be expanded in a whole nother talk. So don't feel bad if you're not following every single item, and I'm glad to sort of have separate follow-ups for some of these things. So this is more sort of a summary of a lot of possible issues. So it might be a little bit quick, but we can go into lunch, right? All right, so let's sort of motivate this in a really general way. Why do we want to encrypt anything in a database? The first point is kind of obvious. That's what everybody thinks, right? That you have data. Data is important. You maybe want to encrypt it to hide it from people who shouldn't see it, right? That's well understood. The other points are maybe less well known, but they're interesting to think about as you explore possible solutions in this area, right? So the second point is sort of what often goes along with encryption. Encryption hides the data from people who shouldn't see it, but possibly you also want to prevent someone from altering the data without authorization, right? Because even if you encrypt something, someone could go in and change the bits and bytes and it's something different, your data is falsified. So you might want to protect against that, right? So we have this in the area of SSL, we sign certificates, right? So we know they're correct. And so this often goes together, right? So that's something to think about. It's not necessarily, I put the question mark there because not necessarily everyone needs that, but it's something to think about. You might want. The term crypto shredding is something that comes up sometimes that is actually quite an interesting application for encryption. What this means is that you might have a requirement at some point to delete some data, right? Oftentimes these are regular requirements or sort of policies that you set for yourself after, 6 months or 7 years, we have to delete data. And it is, if you think about it, often actually quite hard to really delete data. Right? Even if you do it in the database, as we kind of just learned here throughout the morning, that it's not actually deleted, it's marked invisible, basically, right? Until maybe vacuum comes along, but vacuum doesn't actually really delete it. It just sort of marks it for reuse. And then on the file system, it may be still there. And so it's not really gone. And it's sometimes hard to satisfy yourself. Have I actually really deleted that data to satisfy my obligations? And the idea with crypto shredding is if you encrypt the data and you throw the key away, that should be good enough. And so that would arguably satisfy those requirements, right? So if you imagine maybe you sort of partition your data somehow, and then after a while when you need to remove the partition, you just delete the partition as you would normally do, and then also throw away the key that goes with it, and then it's gone. So that's actually a kind of really useful application of encryption. And then you have regulations, policies, laws that apply to what you need to do. Sometimes you might think, like, this is stupid, why do we need to encrypt this? Some regulation says that. It could be laws of, public laws or regulations, or something your company has just defined. The security department in your company says, well, we need to encrypt this, and then you just need to do it. So oftentimes when I engage with customers and explore what you actually want, and then we talk about it in the team maybe, so what are they actually trying to defend against, right? What are they protecting against? And the answer is often They're trying to protect against their internal auditors, right? That's the adversary, right? So it's not. It doesn't really matter why. It's just they say so we have to do it, so we just have to do it. And it's not really our job to become cryptographers and figure out why. It's just we have to do that. Okay, and that's actually quite important in practice. And then the final point is good to keep in mind. Defense in depth means that maybe one thing doesn't protect sort of absolutely. Nothing protects absolutely, right? It doesn't protect absolutely against anything, but if you build a stack of things, like you have firewalls, passwords, just general policies, password rotation, whatever, right? And encryption and privileges and access control and auditing and logging. If you build all of this, then if anything goes wrong that you didn't foresee, the more layers of defense you have, arguably the better, right? So keep those other four in mind just today, but also in general when you think about encryption. It's not just about hiding data, but it's also possibly about some of these other things. Okay. So there's a bunch of different scenarios in which you might run into encryption in the context of a database. And so the first one is, I guess, well solved, right? Transport encryption use SSL. That's, not without challenge to configure correctly sometimes, but it's a pretty well-established thing that you should use. So the other ones I want to talk about is encryption at rest is either encrypting the disk, or you have what some people call TDE, transparent data encryption, so the database manages the encryption, which is not built into Postgres, that facility, but lots of vendors, including my own employer, has proprietary solutions for that. You can use those as well. Now, and that's fine for many people, but when I talk to customers and sort of explain how this works and what are the options and so on, oftentimes, I would say almost half the time, this is not actually what people really were hoping for. But because the encryption at rest is, as the name it's just encrypted on disk, but not in sort of the live system, right? So you protect against, sort of losing your disk, which, is okay, but what people are really hoping for is some kind of scenario where for certain data, the database server doesn't even see that in a plain text way, right? So it is encrypted before it even gets to the server, and then the server can't even see it, and so it's even further protected that way. And that's kind of what I wanted to explore, how you could do that. And this has sort of different terminology. I mean, and obviously in my title, I call it column encryption. In other database systems that don't have columns, that have fields, that they call field encryption. So it's sort of per datum, basically, right? And the important thing when you look through all of that is also that different vendors sort of slice up their terminology differently. Right? In the Postgres sort of ecosystem, I guess we have sort of settled that TDE is encryption at rest, and then I guess column encryption is column encryption, for example. But for example, if you look at Microsoft SQL servers, encryption facilities, they, I believe, call TDE is basically all the encryption facilities that they offer, and then you have full disk encryption, column encryption under TDE, right? And they have some marketing brand names sometimes wrapped around them. So it's sometimes hard to navigate what the high-level terms mean. So kind of just dig into that, right? If you're exploring different solutions. All right. So here's I mentioned regulations. Here are some of the ones you might run into, and there's many more, but these are the good ones to sort of motivate and explore different challenges. And I guess they're also sort of easiest to understand. So, for example, PCI DSS is what you need to follow when you deal with credit cards. And that's actually also kind of a good one that's easy to read. So that's often used as a motivator in context of encryption. Everybody here knows GDPR, right? So that's different, right? PCI is very concrete. You have to do this, you have to do this, you have passwords, you have to rotate them every so often. So it's very concrete. You can follow it relatively easily. GDPR, as many people know, is very general. It's like you have to use state of the art. You have to follow technical and organizational measures and stuff like that. So it's very abstract. You have to kind of interpret into that. FIPS is a standard that applies basically only if you interact with the United States government, but many others sort of voluntarily adopt that, so you will run into that a lot, especially if you deal maybe with customers in North America that are highly regulated. They say, well, we need FIPS. That basically just means you're limited to certain encryption methods that you can use, and they have to be specially certified and so on. And then HIPAA is another one you run into in the US if you deal with medical data, and there's many others. But the thing is, depending on what you do, what your business does, different ones might apply to you, right? If you're in Europe and deal with credit cards, then you need to PCI GDPR. If you're dealing with medical data in the US, you have probably FIPS, HIPAA, and there could be different combinations. So not all of this applies to everyone in the same way, and as we'll see later, this is kind of a challenge as you sort of pick what you need to do. So this is kind of ideally where we want to, sort of the ideal scenario, how we could do this, right? So we have on the client, we want to insert some data, but we don't want the server to see it. So some part in here has to encrypt it. I'm using libpq, but some code here has to encrypt it, and then we want the server to not see what the actual value was. So this is kind of the ideal scenario where we want to get to. And the question is, how could we do this? So I have to put some code here, right? So how could we do this? And so then you start exploring what are possible options to do this. One thing you have to keep in mind if you do this, you have to also make sure your queries are clean in the sense that you don't accidentally leak these sort of values to be encrypted. So you have to use parameters, because whatever component does the encryption needs to know what's your query string, what's your data. If you just write it all in one string, it doesn't know that because the parsing happens on the server, right? So your application code doesn't know what the values is really without doing its own parsing. That's why obviously this is the same problem with SQL and injection. So sort of clean code already does that, right? That you have to use parameters to plug in your values into your query strings. You have to use that. So that's what you have to use when you insert data. If you want to look up things, unencrypted things, that's fine. You can use it either way. How would it work if you want to look up encrypted fields? It's kind of hard, and it depends on sort of what solution you have available. Again, if you write something like this, the secret value gets leaked to the server, so that's bad. This might work if you just plug the pre-encrypted value in here to look it up. That might work, but it might not. We'll talk about that later. Something like that, and I mean, just in general, any kind of operations on the encrypted field obviously won't work in general, right? So this is always the trade-off that you have. If you want to encrypt your data before it gets to the server, you can't do any operations on it, really, right? That's the trade-off you have to use, and that's something you have to manage and think about how far you want to take that. We'll see. We'll talk about that again, have some possible trade-offs there. Why do this, right? I guess what some people do when they have this data has to be more encrypted than this other general data, right? So we have the credit card numbers, PCI DSS says we have to encrypt them. There's all this other data. One thing you could do is just put it in a separate database that's more protected in some way that satisfies your auditors. But I guess the idea is if you combine this all into one database, you have the benefits of your normal integrity in your database that you have. You have referential integrity, you have consistent backups, consistent replication that we just talked about, and so on. If you have it all in one, otherwise separate database, hard to keep in sync, right? So that's some options you could do. Another thing is you could arrange it depending on how you set up the keys that only certain clients can read the encrypted fields because only they have the key. So that's actually could be quite useful, right? And another thing someone else told me as a potential use case was, I'm a little bit skeptical about that, but the third point is you could take your database and kind of copy it to a staging system maybe. And the sensitive fields are encrypted, so the staging system doesn't have access to that. So maybe that's a little bit safer. But you have to think about if that's safe in your environment. So those are some advantages of that. So I think client-side encryption is actually sort of useful security, unlike TDE is a little bit more compliance theater disk encryption, right? If you do it on the client, I think that can actually give you real security, but it's actually quite hard to do. And so that's what I want to explore. The easiest solution that people will make you believe, I guess, is let's just put a proxy in the middle here. And there's commercial solutions out there for this right now that if you look for, Google for certain combinations, you will find these. There's various companies that sell this, that work with Postgres and maybe other database systems. And it kind of makes sense as an architecture, right? You have your unchanged application over here, you have your database over here, and then something in the middle takes care of things. That's what we all kind of want, right? The problem I think as an architecture, this could make sense. The problem I have with the actual solutions that are out there is that they don't really tell you what the question marks are. And that's for encryption, this is always a problem if there's no transparency, at least that's my opinion, right? So they tell you that it's taken care of. Then you ask them, so what do you actually do in there? It's like, well, we have all these certifications and we are FIPS compliant and this and that. It's like, but what is the actual encryption methods that you use? Well, that's proprietary, so I don't know, make your own decisions about that. But that's kind of where it is, right? Yeah, so I guess it is easy to use, but the details are unclear, and you obviously have to get some third-party software that may or may not last as long as your database, right? I guess apart from a proxy, the easiest solution is, which is I guess what many people do now, is that you implement this yourself in the client code. And here's sort of abstract example, which is Python, but you can just import, and this is intentionally vague here, right? You import from some library an encryption function. You get a key from somewhere, and then you write your normal code, but before you insert, you encrypt it. Right? So I guess that would work. I saw somewhere when I was preparing this, Jan is the most common male name in the Netherlands. Is that correct? The second most common one was Peter, so I didn't use that in the example. So that's why all of these ones say on. But I guess this is sort of formally compliant, right? This does the job. But the disadvantage, obviously, you have to do all of this yourself. You have to re-implement this every time you use a different programming language, or every application has to make sure it correctly does this every time I'm dealing with this encrypted column. I have to make sure I really do this correctly. So it's probably going to be very, very difficult to do at scale in a large organization to keep this all in sync. So I guess this is what people do. You can do it now, and if you need to do it. But I guess this is sort of the starting point, and we're kind of looking for a better solution, right? The other thing you will find, if you look for this, and there's always pgcrypto. And pgcrypto is almost always the wrong solution for anything. Unfortunately, it is always there. It's like, yeah, I should encrypt something. Why don't I use pgcrypto? Right? It also has an encrypt function. It's literally called encrypt in this case. And then you can encrypt things. So you give the value, you use your parameter nicely, right? And then, well, but you got to put the key here somewhere. That seems bad, right? To put the key here in plain text, then it's just in your logs. It doesn't. And then you put an encryption method in here. So that's obviously, people do this, but that's obviously bad. You could, instead of just putting the key here in plain text, you could also put it as a parameter maybe, or you can use some function like this to get it from a file, or have any other function you write yourself to get the key from somewhere, but it doesn't feel satisfactory, I think. But you see this a lot, and I'm just basically warning you against it, right? Because it doesn't seem sound. Right? It's also not client-side encryption, which is what people never really tell you. It just does the encryption in the server. So it is kind of a mini TDE. I guess you could use that if you need a TDE solution, but you can't get your hand on one for some reason. You can sort of build your own mini TDE here. You can wrap this all up in views and updatable views, so you can make this probably quite transparent, but it doesn't feel satisfactory, right? The other problem, independent of all of the sort of the architecture considerations, that pgcrypto itself is really antiquated in terms of what cryptography it supports right now. So some of you who might know what all these abbreviations mean here, so AES CBC is really outdated, and it shouldn't really be used anymore in this way. So lots of question marks here. This is actually sort of maybe a nicer solution if you can do it. Many frameworks or ARMS kind of things have sort of usually kind of a plugin or something where you can say just encrypt this field. And this is an example from Django for the Django cryptography extension. That seems pretty nice, right? So you just say this field should be encrypted, done. And underneath it does all of that. Like I showed the Python code earlier. And it calls it all correctly, sets it up correctly. So this is nice if you can use it, right? If you just have your little Django application, then you just use that. That should be okay. But it's obviously not usable if you need to support like a wide range of stacks and combinations in an enterprise. Then this is just sort of an isolated solution for one application. The other thing you need to be careful is there's a lot of, like, for example, for Django, there's a lot of different plugins, and they're not all the same in terms of what they do. Right? So this one I found seems to do the right thing because it does client-side encryption like the Python code I showed earlier, but there's also some Django column encryption plugin that just wraps around pgcrypto, and then it has all the drawbacks of what I just explained about pgcrypto. So you really have to make sure you pick the right one. And I picked the one I showed here. I looked at it for a little while and it seems sound, but there's a lot, and you just really have to evaluate what you pick, not just pick the first one. Right? Because basically everyone can write a Django plugin or a Hibernate plugin or something like that and upload it to the internet, right? It doesn't mean it's good. But if you can use it, if you find the right one, I think this is probably a sound solution. So I think these are sort of basic approaches you can take. We'll get to a couple more complicated ones in a bit. At this point, I want to work through some of the encryption details. And when you're faced with that, I guess if you use this one, you don't have to worry about it because you just say encrypt. But if you hear, then it's like, okay, there's AES, CBC. Which one is that good? I don't know which one. There's all these different acronyms you find, different ciphers and key lengths and modes and initialization vectors, nonces and keys, and where do I get the key from? And so if you want to build this yourself, you have to you should worry about all of that. Many people don't. Right. So here's a couple things to think about. This will maybe come up. You can think the term. Sometimes the terms are slightly different, but I think these are good general terms, right? So we looked earlier at the example, how if I have an encrypted column, let's say I encrypted the credit card number as I'm required by PCI DSS. Now I want to look it up again. That could work because you just encrypt the credit card number in the client in the same way, and then you do a search for the encrypted blob. That could work. So you might think, on a basic level, yeah, if I encrypt the same string or encrypt the same value multiple times, it should always give you the same result, right? So if I encrypt foo, it should give you this. Encrypt foo again should give you this. It kind of makes sense, right? It's just a transformation. And it does do that, but that's generally not what you want. And that's generally not what most systems do. What most systems do, or prefer to do, or recommend you to do, is do randomized encryption. Where are we here? That every time you encrypt something, there's some randomness mixed in, you get a different result. And that's probably what you want in this context, because if you think about it, let's maybe think about an example like a medical database, right? You have like a name, patient name, and then some diagnosis text maybe that you want to encrypt. If the same string always comes to the same value, you don't see what the value is, but you can see the distribution of the values, right? And so if the diagnosis in some, whatever context, you can infer what the context is. Maybe it's all, I don't want to trigger anyone here. Maybe they have a cough, right? That's a diagnosis here, right? So if statistically, statistically 50% of the people who go to doctors just have a cough, then you can just see, okay, well, 50% of the encrypted values of that's probably then that one. So that's really actually bad because it leaks data. So what you really want is every time you encrypt something, you want to have a different result. And then those sort of statistical distributions are hidden. And that's what you should do by default, but then you can't do any queries by that because every value is different, right? So this is a trade-off you can make. I gave the example with sort of a medical database but let's maybe look again at the scenario with credit card numbers. Most of the time, the credit card numbers are only used once ideally, so in that case, you might decide that I'm taking I'm making this conscious trade-off that I'm using deterministic encryption, even though it's technically less secure, but I want to have this additional functionality. So you have to make these trade-offs depending on your application requirements. So there's not like one solution that just would fit everyone. And then the other thing you often see when you look for these kind of solutions is something called homomorphic encryption. So homos is same, morph is shape, I guess, right? So that means encryption of the same shape. And the idea there is that in general, that the result of the encryption process behaves the same as what you encrypted. That's kind of the general idea, and this could have different shapes and behaviors. So here, for example, this is one example, right? You encrypt a string, you get a string. You encrypt a number, you get a number, for example, right? So it has sort of the same shape at the end. Or also, more interestingly, the same operations can be done, right? So if you concatenate two strings, it's the same as the concatenation of the encryption, or sometimes it allows substrings and things like that. So there's a whole variety of different homomorphic encryption methods that have certain properties. Sometimes you can maybe do addition of numbers or something like that, right? You will see this a lot because it is nice. It solves this issue like, well, I've encrypted the values, but I can't do any computation with them in the database. Well, and then you like, how can I solve this problem? Like, use homomorphic encryption. That's what it is for. But the problem, at least according to my research, this is all very dubious because these homomorphic encryption methods all found to be insecure in some way, or not certified, not widely scrutinized, and every couple of months someone comes up with a new one, and they have a mathematical proof that it does this or that, but it's again a warning against that. For example, one sort of subset of homomorphic encryption is also order-preserving encryption, so that the encrypted strings order in the same way, so you can maybe do sort of statistical analysis on the encrypted values if you want to. Well, that is bad, I think, because let's think of an example. You have a plain text name and maybe an encrypted salary, for example, right? You don't want to show the salary, so you encrypt it. But then if the encryption is order-preserving, then you still show data. If you see the whole table, you see, well, I don't know what the actual salary is, but I know I'm like up here or down there, right? So I think that's just bad. So I would really stay away from that unless you really know what you're doing. There are solutions. I read about something sort of in the lead up to this, which I think is like a valuable application for this, for example, where if you have a smartphone, a lot of them can do call screening now, sort of if there's like a number known as spam or sort of a annoying caller that you want to block. And so the phone would look up the number in some service, and the service say block this, right? But this should be encrypted because otherwise whatever that service is knows all the people who have called you. So ideally they don't want to know that. And they can also do sort of prefix lookups and stuff like that. So if you really design this as a closed system, like I really know I'm only looking up phone numbers, I'm only doing this, then you can pick a homomorphic encryption method if you have people in your team who know what they're doing. But as a general, just like fix everything solution, I would really warn against that. This is also maybe something that's not considered. If you have a short string encrypted, you get a short encrypted output, right? If you have a longer string, you have a longer output. That could leak data, right? If you have some kind of idea of what's in your database. So maybe the most common value is none, and then you get something short, and if the text is longer, then you don't know what the text is, but there's there's a lot of information in here, right? This person maybe has lots of things being said about them, right? So that could leak some information. So this is hard to avoid in general, but some encryption methods do is they pad things at least to some sort of multiple of 16 usually, and something like that, that can hide that. But it is very difficult to do this in general. That seems to be, in my research, essentially an unsolved problem. Now you could say all my strings are at most 1,000 characters, you pad to 1,000 characters, that's okay. But if you don't know, then it's a waste space and stuff like that, right? Or you could say, like, I add a random amount of padding. Maybe that's an interesting idea, but it turns out that's actually also not good. So there's all mathematical proofs about that and stuff like that, that no padding method will actually work. So that's unfortunate. So yeah, so keep that in mind also, maybe. I think this sort of padding to 16 bytes is probably okay as a start, but you have to kind of be careful about that. And so this is the thing I'm struggling with as the implementer here, right? These are all like, okay, what mode can I use? And then ideally you want to have yes in all of these fields here, and as you can see, there's no one that is like just yes everywhere, right? And so depending on what you need, like ideally you want your encryption mode to be some kind of standard, right? Maybe RFC something or other, that'd be good. But a lot of these commonly used ones are not, right? I mean, somebody published it somewhere, but there's no what you would call a standard for it, right? Well, not all of them support padding. There's other issues, right? Some of you talked about integrity at the beginning. Not all of them do that. If you have a FIPS requirement, for example, then not all of them are in the FIPS standard at this time, so you can't use them. Ideally, also, if you want to implement this in some system, it might be nice if that mode was supported in a library like OpenSSL or JDK, so you can see, well, not all of them are here, and so that's, up. It's too much information here, right? So yeah, I mean, this is basically the thing where I'm stuck with at this point. You could say like, well, this one is actually, if you dig into the detail, this one is actually kind of the nicest one. But it's not in FIPS, so that's 50% of our customers would just not want that. And it's only implemented in OpenSSL 3.2, which is very recent, so it's not even like deployed in any system. So it's just practically not useful, right? Or the first one is also kind of okay. The details here we can talk endlessly, but it's not standard. So somebody says, well, this is a method that's not standard. It's very commonly used. But there's no standard document, so it's the auditors will reject it. So it's just bad, right? So you can pick one, but it's only going to be for your scenario. It makes it very hard to just provide a library or something I'll show in a minute, like a general solution that we can just ship to the wider public and say, well, yeah, we picked the right one and it's the one you should use. No, you got to make your own choice or trade-off. It's just hard. And this is also, of course, the best one and that people use. I read an article about this, like somebody said, like, well, this is actually good, but it's not FIPS because there's some computation in there that's not FIPS certified, so I'm changing that to a different one. So it's kind of like that, but I've added my own tweak to it. So you can implement it with FIPS compliant sort of steps in a way. But then it's your own, right? It's not standard, and you're responsible for yourself. So it's just madness. All right, let's look at a couple more solutions that actually is a little more advanced. This is actually sort of you could summarize this as a better pgcrypto. This is actually quite nice. pgsodium, so libsodium is a encryption library. pgsodium is a Postgres extension on top of that. And it's very sophisticated. You can create keys, and it uses this sort of trick, I guess, with the security labels that you say, well, encrypt this column, this one here, right? And it does a lot of things in the background, sets up views, event triggers, and stuff like that, and just encrypts it. So it is actually quite nice. It uses this algorithm down here, xcharger20 SIV, which is not anything here. It is good, I think, right? But it's if somebody says like, hey, how about FIPS? How about standard? Like, no, it's just that. It's good. But if you are, if your main adversary are your auditors, then that's not a good solution. But I think it is actually quite sound. And it is much more modern than pgsodium. It actually goes quite deep in terms of what features it provides. So I think it is definitely worth checking out if this is the kind of thing, if you think in pgcrypto, think that, I would say, basically. That's the summary. Right? It is still server-side encryption, but it is much more isolated. So I think that's worth checking out. It is a third-party extension, so it might not be available everywhere, but it's actually quite widely deployed nowadays. And this is what I've kind of been working toward, to have this built into Postgres. And there is a patch for that. And this is sort of the way it could look. Right, that you set up some keys, and then you tag the column, say, I want to encrypt this, and then you set which key you want to use, and then, for example, this would be the idea that you can then choose here, do I want deterministic encryption or randomized encryption? Or maybe if we feel daring enough in the future, we could say, I want to have some kind of homomorphic encryption here that you could use that here as well as an alternative if you want. And then based on what you choose here, certain operations, the server would just allow them or not. I think that could work quite well. I mean, the patch does work. But this is basically one of the big problems, like, what do we do here? Which one of these do we implement? Do we just give the users, like, well, here, pick one out of these 8. Good luck, right? That's not really good experience. So this is kind of where this is stuck right now. But at least I would like to get to that, because I think, there's a lot of subtleties and problems here, and I think if we could provide a better solution that solves that for a lot of people, I think that would be helpful, but it's not done yet. There's also a couple of, where are we at the time here? Yeah, there's a couple of maybe also other challenges. If you do encryption in the client, the server can't actually check what you put in that column, right? You say it's an integer column that's encrypted, but the server can't see what you put in there, so it doesn't actually know if it's an integer. It's maybe not always a problem, but that's not a possibility, right? There's no possibility for the server to enforce data types and formats and things like that, or encodings and things like that. So also something to think about. And so one thing we've skipped over here is key management, and that's a whole nother topic. But going back to this sort of simple scenario at the beginning is, somewhere in this pipeline, we want to do the encryption, right? It could be either here in the application code, or in the client library, or maybe in the proxy here, or someone has to do the encryption. And I mentioned there's I had some variables here that says key. Where does the key actually come from, right? You could make a key. A key is just a sequence of bits, right? 128-bit key, 256-bit key, and you could put it in a file somewhere, and then it's your key. That's sort of the basic scenario. But what you actually want is a key management system. Those are software components. Many of you will probably have this in your organization already for various other reasons. There's various bunch of commercial products that do this. They just manage keys. And you can use that for all kinds of things, SSL certificates and revoking them, and it does all that kind of stuff, rotation of keys and so on and so on. But you have to connect this somehow, right? And that's, well, it's a simple matter of programming in a sense, right? They have APIs, you call out, give me the key. But all of these key management systems, at least that's my experience, they're all very crafty and weird to deal with, this enterprise software ultimately, right? And they have sort of poorly documented APIs, and so that's a whole another challenge. Whatever solution you come up with, can they talk to a key management system, your key management system? and is that like robust and well tested? And there's actually a protocol, a standardized protocol, key management interoperability protocol, KMIP, which we'll come up with in this context, but that's also terrible. I mean, let me tell you, I think the I stands for interoperability. I have not seen anything that's actually interoperable yet. Very poorly documented, but very widely used. So you still have to basically test each key management system individually, right? Don't be fooled by like, oh, this speaks KMIP, great. No, that's not. So that's a whole another problem space here that we'll come up with in this scenario. So whatever solution you have, make sure it talks to whatever key management expectations the organization has. Here's just some examples of different key management server products. There's different key rotation requirements. So in my sample code here, I have a 2-key architecture. There's a master key which encrypts another key, which is the actual key that's used. That's kind of a common scenario. What's nice about this, if you need to rotate the key, you can rotate the master key very easily because it doesn't actually encrypt any data. It encrypts just another key, which is a very small operation to change. If you need to rotate the actual column encryption key, you have to rewrite your entire database, right? This is the problem with that. So that's why usually any system that works like that, be it TDE or disk encryption in the operating system, they usually have like 2, 3, or 4 levels of keys to make it easier to rotate the various levels of keys, because there's, again, requirements. You have to rotate your key every 2 years, which everybody asks about. Nobody actually ever does, I think. But you have to at least think about that to have an answer for your auditors. All right. Secure enclave is a piece of hardware that sometimes exists and it does, sort of secure boot and various things like that. But what some also do is that you can load sort of operations into the secure enclave. So you could do operations on encrypted columns because the secure enclave decrypts them. You can do things, and then that's a good idea. It is implemented in other systems that are not Postgres. But again, it turned out that's not secure, because those kind of things leak things. These things nowadays, you can just listen to the CPUs and get bits out of that way, right? Or sort of measure the heat of the CPU, or what people do nowadays, right? So these kind of things are not secure. So that kind of hardware is going away. So that's not really anything that's going to help you practically. Another nice feature idea is that you can encrypt a column and have integrity protection, for example, and that will make it secure as the column. But what an adversary could do is actually swap column values, right, into different rows. Nothing prevents that in sort of this basic scenario. So another thing to think about as, well, that's mainly for me as a sort of a feature. It's kind of hard to implement by hand, to tie these encrypted values via some kind of signature to the primary key, so you can't swap them out. That might be nice, but it's obviously much harder. Anyway, well, let's skip to the end here. We're almost out of time. As an advice, obviously look for solutions that are mature and general and fit your scenarios in terms of compliance and these kind of requirements that we talked about at the beginning. pgcrypto, as I mentioned, is almost always the wrong solution. Maybe consider pgsodium if you want that kind of setup. I think pgsodium is quite nice. I think the Django plugins, some of them are also quite nice. Some of these proxy solutions may be good, but I don't know what's in them, right? I think they make sense maybe, but I don't know what's in them. So those are the kind of solutions I would say are okay. Again, homomorphic encryption is probably dubious. So that's a lot of marketing message often in that. It's like it fixes all of the problems, but maybe not. So I would like feedback. We don't have time now, but maybe during lunch or also, over the next days, weeks, months, years. If any of this is sort of interesting, you have some scenarios, give me some feedback on use cases and what you want to do. And I want to work toward simplifying the space, basically. And I hope I gave you maybe more questions than answers, but I guess that's the situation we're in. That is all for me. We have 54 seconds. I think we're up against lunch, so we can have as many questions as we want.
Yeah. Thank you.